Next one is ideal current source. What we understood from the voltage source. Voltage source is represented with plus and minus. So ideal current source comes under the category of what? Independent or dependent? Independent. Independent sources are represented with circle. Independent sources are represented with circle. So circle with an arrow. Circle with an arrow. So then we can call it as a current source. Okay. So same thing, same story here. And here the load voltage is VL. Always the current flows from higher potential to lower potential. This is the current direction. This is the current direction. Current is flowing through the load. Current is always flows from higher potential to lower potential. And what is the definition of an ideal current source? As we discussed, the ideal sources are not existing. Ideal sources are not existing. So ideal current source delivers the energy. Which is independent on voltage across the load. Okay, see here, same story. I have 5 rupees, entire 5 rupees is going to the load only. What is the load current now? What is the load current? IL is equal to IS. Because series the current is same. IL is equal to IS, which is not possible. As you vary the load voltage, IL is equal to IS only. This is not at all possible. You have to decrease the current. See, as I am going for the practical current source now, practical current source value. So this is the IS now. Load I am connecting here. The current which is flowing through the load is IL, but you have to decrease the current. Now tell me, in series the current is same. But in order to decrease the current, you can connect one resistance in parallel with the source value. So this is called the practical current source symbolic representation, and this resistance is called the RP. So there we call the RS in a practical current source. In order to differentiate the series resistance and shunt resistance, I can write it as the RP here. And see, simple, current and resistance both are having inverse relationships. What is the electric current? Flow of free electrons. What is the resistance property? It opposes the flow of free electrons. Is called the resistance. And if suppose I am having a 5 amperes here, and here I want to go for the 4.9 amperes. Okay, and here only 0.1 amperes is going through this value. What I said, the current value is lower. Whatever the resistance you have to design, RP value you have to design with a very higher value, with very high value. So then only RP value is increases, then the current value will be decreases. Most of the current passes through the load only. Suppose if you have the equal values of the resistance, see, I have a 5 rupees in my pocket, and this 5 rupees, whatever the 5 rupees is there, and this is also equal values of resistance, R and R, 2% are there. So if I am giving here 2.5 amperes and here also 2.5 amperes, but what is the output here? 2.5. So what I have? 5 rupees. So how much amount is wasted? Half of the amount is wasted. That is 50% of the amount is wasted. So that's why you have to decrease the current. You have to decrease the current which is flowing through RP. So you can increase the RP value resistance. This is very important. Internal resistance of practical current source. A practical current source internal resistance of practical current source value will be high. Simply say it is very high, right? But what will happen? See, here there is no current is flowing this wires, two wires, it is a open circuited now. Then only entire current is passed through the load value. If no current is flowing, I is equal to 0, means what is the resistance value? Infinity. This is very, very important. The internal resistance of ideal current source is infinite. Why? Because see, this is a open circuited properties. There is no wire here. Here phase is there, neutral is there. Suppose this hand is neutral, this hand is phase. Is there any current is flowing between these two? No current. What is the resistance offered? Infinity between these 2 points. But if a person is touches the phase and one more hand is on neutral, what will happen? Current passes through the body, means body consisting of a resistance, he will get shock. Simply you have to remember one thing, whenever in an open circuit voltage is existing, but what is the current which is flowing in an open circuit wire? 0. Take a battery, 9 volts battery. So with the help of a multimeter you can measure it. Then it shows 9 volts, but there is no current. And in our phone also we are having a battery. Battery is charged to full 4.8 volts or 4.9 volts. 100% it is charged. But once it will be inserted into your phone, the phone function will be starts whenever it is switched on. Similarly, same way, whenever the closed path is there, the current will be flows. Whenever closed path is not there, there is no current. So in an open circuit, what you understand, voltage is existing. The best example you have to take, the best example is a phone battery. Okay, so and coming to here, so the load current S, which is independent of the voltage across the load or not. If you increase this RP value, what will happen? IL value will be decreases. If you decrease the RP value, IL increases. If you increase the RP value, IL value will be decreases. Vice versa. Okay. So which is depending upon the voltage across the load. So 4.9 into suppose 1 ohm, that is 4.9 volts. Suppose if it is decreases to 4 amperes only, 4 into 1, that should be equal to 4 volts, right? It depends upon the load voltage. Okay. Now, so what is our conclusion points? Internal resistance of ideal voltage source is 0. Internal resistance of practical voltage source is small, and internal resistance of, these are very, very important objective bits. Internal resistance of ideal current source, I dot means ideal current source, is infinite, and internal resistance of practical current source is high value. And these are the conclusion points from ideal voltage source and ideal current source and practical current source. Okay, so now